Hello students, I hope all are fine. So welcome to my channel. So today we are going to do exercise 3.3, and as I have explained everything related to exercise 3.3, I hope all of you understood and you have gone through the videos. So now you want to start exercise 3.3. So number 1, if A divides B, then show that minus A divides B, A divides minus B, and minus A divides minus B. So one we have to prove minus A divides B, A minus divide minus B, and minus A divide minus B. So this is what we have to show. So it is very simple. So already I have done half of the part. It takes much time. So I have been doing the sums. So you can follow this. So first of all, since A divides B, so B by A equals to K. It means if 15 divides 30, that means 30 is divisible by 15. A divides B. A divides B, or 15 divides 30, same meaning. It means that 30 by 15 is 2. 30 by 15 is 2, because 15 to the 30, that you know. That means what? B by A equals to K. This is an integer, any number. So this one I hope you understand. So since A divides B, so B by A equals to K. Since 15 divides 30, so 30 by 15 equals to 2, same meaning. So this is what written, B by A equals to K. So B equals to AK. So I hope you understood this much. Secondly, putting just a value K in place of K, just minus 1. So minus 1, so B equals to minus A into minus 1. K is minus 1, so A into minus 1 is minus A. So B equals to minus A. B equals to minus A, or we can write B equals to minus A, or we can write B equals to A into minus 1, or B equals to minus 1 into A, same meaning. It is same meaning. It means what? B by A equals to minus 1. That means if we divide B by A, or if A divides B, then we get minus 1. Or if we can think this way also, if A divides B, we get something, that is integer, any integer. So if B divides minus A, that means minus A divides B. So B equals to minus A, that means minus A divides B. So minus A divides B. Minus B equals to minus A. So minus A divides B. So this one we can write this way. To make you understand, I am writing this one this way. Minus A into 1. That means what? B by minus A equals to 1. That means minus by minus A, if we divide B, we get 1. Meaning is same. This line, and this line, meaning is same. I hope you understand. B equals to minus A, we can write B equals to minus A into 1. We can write B by minus A equals to 1. So this means, what is the meaning of this? That minus A divides B. That means B is divisible by minus A, and answer is 1. Quotient is 1, like this 2. Here it is 1. So minus A divides B. So secondly, this one we have proved. Secondly, what we have to prove? A divides minus B. So we have got already B equals to minus A. So B equals to minus A. So just multiplying both sides by minus. Minus into B, minus B, minus into minus A, plus A. So minus B equals to A. That means A divides minus B. This one also I want to explain. Minus B equals to A. So minus B is equal to A into 1. So minus B by A equals to 1. That means minus B, if we divide by A, we get 1. That means what? A divides minus B. So A divides minus B. So this one also proved. Here we have put k equals to minus 1. Now let us put k equals to 1. B equals to ak. Just we are going to put k equals to 1. So if k equals to 1, then b equals to a, b equals to a. Both sides multiplying by minus. So minus into b minus into a minus. Why we are multiplying by minus? Because we have to prove minus a divides minus b. So minus b equals to minus a. This one also I want to explain. Minus b equals to minus a. Or we can write minus b equals to 1 into minus a. Or minus b divided by minus a equals to 1. This one I hope you understand. That means minus b is divisible by minus a, or in other words, how can we say minus a divides minus b? If we divide minus b by minus a, we get 1. So that is why minus a divides minus b. This one proved. So this is also proved. So this is the proof. This is very easy actually. Just our way of thinking must be correct. Just to think only. Psychologically you have to think the things when what to put. In place of k equals to minus 1, we have got something. In place of k equals to 1, we have got something. So this is the technique you have to apply for the sums. Number 2. Same thing. For given integer, for given integers a, b, c and d. A, b, c and d all are integers. A, b, c, d all are integers. So what is given? A by a divides b, it is given. A by a divides b, it is given. A divides c, it is given. So since a divides b, so b by a equals to m taken. So very simple, like in previous sum I already explained you that if we divide b by a, we will get something. One integer, one number we will get. That is what we have taken, just let m, because b and a we don't know what the numbers. A divides b. So b, if we divide by a, we get here m. That is what we are doing here. A divides b, that means b by a equals to m. So it is like the same thing. 30 divided by 15, 2. So this is a, this is b, this is m. So b by a equals to m. So b by a equals to m. M is just taken let, and that is integer. So b equals to am. B equals to a into m, am. Similarly, a divides c. So c by a equals to another integer. We have taken left. That is integer. So c equals to an. Now what to prove? It is required to prove that a square divides bc. We have to prove that a square divides bc. So here we have to get something. A square into how much is bc? That is what we have to find. That means what? bc by a square equals to, we have to get one integer. Any integer. Any. BC, if we divide by a square, we have to get something because it's divisible. So that is what we are going to get. So BC by a square equals to, let us see whether we get any integers or not. So BC by a square, let us see whether, what do we get? B equals to am. So in place of b, am written. C equals to an, in place of c, an written. So you can put into multiplication sign. So a square. Denominator is a square. So a square, a into a square, m n. So we have got BC by a square is equal to mn. M is integer, n is also integer. So multiplication of both the integers will be integers only. So BC by a square is equal to, we have got one integer. Therefore, a square divides BC. As I have already explained, BC by a square, we have to get one integer, one number. What is that? mn. Mn integer, any integer. So BC by a square equals to any integer we have got. That means what? A square divides BC. That is what we have to prove. Number 3. Examine if the following statements are true or false. Supply proof when it is true and give counter example when it is false. So, if it is true, we have to prove. If it is not true, if it is false, we have to give some counter example. So, it is given here A divides B plus C, then A will divide B and A will also divide C. So, we have taken the simple example. 2 divides 5 plus 3. Let us see now 2 divides 5 or not, 2 divides 3 or not separately. Separately, because A divides B written here, A divides C written here separately. So now 2 divides, of course, 5 plus 3. 5 plus 3 means 8. 2 4 is 8. 2 divides 8. 8 is divisible by 2. So 8 is written 5 plus 3. But 2 doesn't divide 5. 2 doesn't divide 5. 2 also doesn't divide 3. So it is false. This is false. If A divides B plus C, so A will never divide B, A will never divide C. May not be never, sometimes it may be, but it is false. It is not always true. It is not always true. Look here. 5 divides 4 plus 6. 4 plus 6 is 10. 4 plus 6 is 10. Surely 5 divides 10. 5 2 is 10. But 5 doesn't divide 4. 5 doesn't divide 6. So in some cases it may be 5 divide 10 plus 5 15. 5 divides 10. 5 divides 5. It is okay. But somewhere it is wrong. So if it is always true, then only you can say true. Only in one case if it is false, so it is false. Next, number 2. If A divides N, it is given B divides N, then AB divides N, we have to show whether it is true or false. Now, so for example, this A and this N and this N same. So 90 and 90. A divides N, B divides N. 6 divides 90, 10 divides 90. 6 15s are 90 and 10 9s are 90. So 90 is divisible by 6 and 90 is also divisible by 10. But AB means 6 into 10, 60. AB doesn't divide 90. AB does not divide 90. So this is also false. I hope you understand the what is called example. Because it is given here, give counter example when it is false. So we have given counter example. One more example. If 9 divides 18 and 3 divides 18, this is N, this is N, this is A, this is B. A divides N, B divides N. It means 9 divides 18, 3 divides 18. That means 18 is divisible by 9, 18 also divisible by 9. But 9 3s are 27, doesn't divide 18. I hope you understand. So this statement is false. Now number 4. For any natural number n, show that 2 to the power n, 2 to the power n plus minus 1 to the power n plus 1 is divisible by 3. So divisible by 3 in previous exercise we have done already. In the previous exercise, that means exercise 3.2, already we have done divisible by 3. So I have done. So because the same thing we have been repeating again and again. So in previous exercise we have done when divisible case, in divisibility case we do for first Sn, then S1, Sk we have taken assume already. You can check. You can go back to exercise 3.2 and you can check it. Then first case S1 we have to show that is true. Second case Sk will be true, which we will assume. Third case, we have to prove as k plus 1 is also true. This is what we have to do here also. Okay. So first of all, we have taken Sn. Whatever term is given, this one we have taken, let Sn equals to 2 to the power n plus minus 1 to the power n plus 1 is divisible by 3. So in place of n, 1. So this is the case, 1, S1. That means in place of 1, in place of n, we will write 1. So 2 to the power n, so 2 to the power 1 plus minus 1 to the power 1 plus 1. So 2 to the power 1 is 2 plus minus 1 to the power 2. Minus 1 to the power 2. So minus 1 square is 1, 2 plus 1 is 3. So 3 is surely divisible by 3. So S1 is finished. S1 is finished. S1 is true for n equals to 1. So this first case is finished. This one already you have proved. Second, as we have done in exercise 3.2, let us assume Sk 2 to the power, means in place of n now k comes. So 2 to the power k, 2 to the power n will be 2 to the power k plus minus 1 to the power k plus 1 is divisible by 3, which is true for n equals to k. This is the statement always you have to remember. This is the statement always you have to remember, and always you have to use this for Sk. So that is why 2 to the power k minus 1 k plus 1 equals to 3m. This term is divisible by 3. Divisible by 3. So 2 to the power k plus minus 1 to the power k plus 1 equals 3m. Because this is divisible by 3 into something. M is integer. 3m, why we have written? Because divisible by 3. If it is divisible by 7, then we could have written here 7m. 7m. So suppose we have got 2 to the power n plus 5 to the power n plus 1 equals to 3k. Okay. 3n. That means this term is divisible by 3, because this equals 3 into something. So as already we have got 2 to the power k plus minus 1 to the power k plus 1 is divisible by 3. So 2 to the power k plus minus 1 to the power k plus 1 equals 3 to the power m. This one we have taken let m belongs to integer. Now what is to prove? Second case is finished. Second case is finished. Third case, now to prove that as k plus 1, what is k? In place of n, k plus 1 comes now. 2 to the power n will be 2 to the power k plus 1 minus 1 to the power n minus 1 to the power n means k plus 1. Again one more plus 1 is there. So it is divisible by 3, which is true for n equals to k plus 1. So to prove, we have to prove now. It is not proved. We have to prove this is also divisible by 3. So this term let us write again, so that we can do the sum easily. I have already written, I think. Yes. This term let me write in this page. 2 to the power k plus minus 1 to the power k plus 1 equals to 3m. Okay. Now what is to prove? That 2 to the power k plus 1 plus minus 1 to the power k plus 1 is divisible by 3. This is what we have to prove. So let us prove now. So 2 to the power k plus 1 plus, sorry, it is written. So 2 to the power k plus 1, we can write 2 to the power k into 2 to the power 1 minus 1 to the power k plus 1 into minus 1 to the power 1 written separately, 1. Now 2 to the power 2 into 2 to the power k, just written same thing, minus 1 to the power k plus 1. So minus 1 into plus is minus. This one I hope you understand. So in place of minus 1 to the power k plus 1, minus 1 to the power k plus 1, we can write 3m minus 2 to the power k. In place of minus 1 to the power k plus 1, we can, from previous page, here also it is written. So 3m minus 2 to the power k. Okay, this one. Okay. Now 2 into 2 to the power k minus 3m plus 2 to the power k. I hope this one you understand. Minus into 3m is minus 3m, minus into minus 2k is plus 2 to the power k. Now 2 into 2 to the power k plus 2 to the power k is 3 into 2 to the power k. How it is? Look here. 2 into 2 to the power k plus 2 to the power k. How can we write this one? 2 into 2 to the power k plus 1 into 2 to the power k. Same thing. It is like this: 2x plus 1x equals to 3x. 2x plus 1x equals to 3x. So 2x plus 1x equals to 3x. What is x? This is x. 2x plus 1x is 3x. What is x? 3 into 2 to the power k. 3 into x. 3x means 3 into x. So 3 into 2 to the power k. I hope you understand. Minus 3 to the 3m. Now we can take 3 common. 2 to the power k minus m. 2 to the power k plus 1 plus minus 1 to the power k plus 1 is equal to 3 into something. 3 into something is divisible by 3. 3 into something means divisible by 3. This equals to 3. Suppose this equals to, suppose we have got 30. Suppose. Then you can add 3 into 10. You can add 3 into m, 3 into k, 3 into anything. So 3 into anything will be divisible by 3. So 2 to the power, therefore we can write 2 to the power k plus 1. Wait. Now 3p. We can write in place of 2 to the power k minus m, because this k is integer, m is integer. So altogether one integer is taken. Let p belongs to z, any integer. So therefore 2 to the power k plus 1, 2 to the power k plus 1 plus minus 1 to the power k plus 1 is divisible by 3 for n equals to k plus 1, because this equals to 3 into something we have got. If it is divisible by 5, we have to try to get 5 into something. If it in any question, if it is written that divisible by 7, here it is written divisible by 3. We have to prove this is divisible by 3. So we will try to get 3 into something. If in the question it is written divisible by 5, then we will try to get 5 into something. 5 into any integer, then it will be surely divisible by 5. So what we are trying to get here? We have tried to get 3m. Here we have got 3p, 3 into. So that is divisible by 3. So therefore actually what is the question? 2 to the power n plus minus 1 to the power n plus 1 is divisible by 3. This is the conclusion. This is what at last you have to write. This is divisible by 5. This question is written divisible by 5. As I have told you already. Divisible by, to show that 3 to the power 3n plus 1 plus 2 to the power n plus 1 is divisible by 5. This is question number 4. Question number 4.2. Exercise 3.3, number 4a2. So in the previous sum divisible by 3 it was. So we have tried to get 3 into something. So here we will try to get 5. Same process. S1, Sk, k plus 1. So Sn equals to the term is taken. Then S1 is written by putting in place of n1. Calculation is done 85. 85 is divisible by 5. Putting the value of n as 1, we have got 85. So it is divisible by 5. S1 is finished. S1 is finished. Then Sk, assume same thing. In place of n, we will write just k. 3k plus 1. K plus 1 is divisible by 5, which is true for n equals to k. So in place of this, we have taken one number, that is 5m. In the previous sum, we have taken 3m. because divisible by 3. This is divisible by 5, so we have taken 5m. I hope you understand. Now we have to prove that as k plus 1, 3 into, in place of n now k plus 1, 3n plus 1, 3 into k plus 1 plus 2 into the power k plus 1 plus 1. K plus 1 is divisible by 5, which is true for n equals to k plus. We have to prove. To prove that, we are going to prove it. So this will be required. Like previous sum, this will be required. Three to the power 3k plus 1, 3 to the power 3k plus 1 plus 2 to the power k plus 1 plus 2 to the power k plus 1 equals to 5m. Now we have to prove 3 to the power. What is to prove? To prove that 3 to the power k plus 1, 3 to the power 3 into k plus 1 plus 1 plus 2 to the power k plus 1 plus 1 is divisible by 5. This is what just I have written here. So 3 to the power 3 into k, 3k, 3 into 1, 3 plus 1 separately. Then 2 to the power k plus 1 separately and 2 to the power 1 again separately. So this one you know, I think. This one is related to general maths. So 3 to the power 3k plus 1 taken together. Why 3k plus 1 taken together? 3 is taken. 3 to the power 3 is taken separately because previous one 3 to the power 3k plus 1 is present. So we are trying to get 3 to the power 3k plus 1. There should be some meaning. Simply we cannot take any number. So 3 to the power 3k plus 1 taken separately, 3 to the power 3 written separately, plus in place of 2 to the power k plus 1, 2 to the power k plus 1 is equal to 5m minus 3 to the power 3k plus 1. 5m, this 3 to the power 3k plus 1 goes that side. So in place of 2 to the power k plus 1, 5m minus 3 to the power 3k plus 1 is written. Into 2, 2 is as it is. So 2 into 5, 10m, 2 into 3 to the power 3k plus 1 as it is. Okay. Now 27 into 3 to the power 3k plus 1 minus 2 into 3 to the power 3k plus 1. So this one also I will explain it. 27 into 3 to the power 3k plus 1 minus 2 into 3 to the power 3k plus 1. It is like this. 27x means 27 into x minus 2x is equals to 25x. So 27x minus 2x equals to 25x. What is x? 3 to the power 3k plus 1. I hope you understand. So here we are trying to get divisible by 5. So you will try to get 5 into something. So you will take 5 common here. 5 just common. 5 is common. So 5 into 3 to the power 3k plus 1 plus 2m. Just taking common. In place of this we will take now p. Let p equals to 5 into 3 to the power 3k plus 1 plus 2m belongs to z. So this equals to 5p. Therefore 3 to the power 3 into k plus 1, or we can write directly as k plus 1, that is 3 to the power 3 to the k plus 1 plus 1 plus 2 to the power k plus 1 plus 1 is divisible by 5 for n equals to k plus 1, like previous exercise. So therefore 3 to the power 3n plus 1 plus 2 to the power n plus 1, I hope this one, 3 to the power 3n plus 1, 3 to the power 3n plus 1 plus 2 to the power 1 is divisible by 5. Same thing here, things are same. Here the question is written divisible by 7 now, whatever it is given. Divisible by 7. 3 to the power 2n minus 1 plus 2 to the power n plus 1 is divisible by 7. So same thing we will do, s1, sk plus 1. Same thing. So first we have whatever term it is given, we have taken Sn divisible by 7. Divisible by 7. So in place of n we have put like other sums, just 1, 3 to the power 2 minus 1 equals to 7. So by putting 1 we have got this term equals to 7. So 7 is surely divisible by 7. Sk, assume same thing. So 3 to the power 2k minus 1k plus 1 equals to 7m, like previous sum. 7m. Now to prove that sk plus 1, 3 to the power 2k plus 1, this one is divisible by 7. Same, exactly same. So 3 to the power 2 into k plus 1, this one already I have written here. 3 to the power 2 into k plus 1 minus 1. I hope this one you understand. 3 to the power 2, in place of n what we have to write, k plus 1. So 3 to the power 2 k plus 1 minus 1 plus 2 to the power k plus 1, in place of n k plus 1, then plus 1. This is what I have written here again. So we will try to get 7 into something. 7 into something. So 3 to the power 2 into k, 2k, 2 into 1, 2 minus 1. 2 to the power k plus 1. So 2 to the power k plus 1 kept as separately, and 2 to the power 1 means 2 only taken. So I hope this one you understand. 2 to the power k plus 1 plus 1, or 2 to the power k plus 1 into 2 to the power 1. This one and this one same. I hope you understand this one. This is just simple only. Okay. Now 3 to the power 2k minus 1 taken separately. Why? Here 3 to the power 2k minus 1 is there. This one has come from previous page. This one. 3 to the power 2k minus 1 plus 2 to the power k plus 1 equals to 7m. So 3 to the power 2k minus 1 taken separately. Why? Because it is there. And 3 to the power 2 is taken separately. In place of 2 to the power k plus 1, 2 to the power k plus 1 is equal to 7m minus 7m minus 3 to the power 2k minus 1. 2 to the power k plus 1 is equal to 7m. This one goes that side. So in place of 2 to the power k plus 1, 7m minus 3 to the power 2k minus 1. So 2 into 7m, 14m, 2 into 3 to the power 2k minus 1. So 9x minus 2x, 7x, what is x? 2k minus 1. 3 to the power 2k minus 1 is x. I repeat, 9x minus 2x, what is x? So 7x plus 14. What is our aim? We have to try to get 7 into something. So 7 common. 3 to the power 2k minus 1 plus 2m. So 7p. In place of this integer, this complex integer, there are 2, 3, k is there, m is there. So altogether I have taken p, also an integer. So let p equals to 3 to the power 2k minus 1 plus 2m belongs to z. So this equals to 7p. Therefore, as k plus 1 is divisible by 7 for n equals to k plus 1. So S1 is divisible by 7 for n equals to 1. Sk is divisible by 7 for k n equals to k. Sk plus 1 is divisible by 7 for n equals to k plus 1. So 1 is true, k is true, k plus 1 is true. Therefore, so Sn, or directly we can write 2 to the power 3 to the power 2n plus minus 1, sorry, minus 1, 2 to the power n minus 1 plus 2 to the power n plus 1 is divisible by 7. Now divisible by 14. So same process is same. There is no difference in the process. So we will try to get 14 into something. Previous first one 3, second one 5, third one 7, now fourth one 14. 4C. 4C. 3 to the power 4n plus 2 plus 5 to the power 2n plus 1 is divisible by 14. So first Sn, this one is taken as Sn, then S1 by calculation. You will just pause the video and you will see the calculation. I have done the calculation. 850. I have done the calculation already because to minimize the time spending. Because it takes much time. Same thing again and again doing, taking just time only. So you can pause the video, you can note it down and you can understand this one. So 850, by putting n equals to 1, we have got 854. 854 is divisible by 14 because I have shown here. 14 into 61 is 854. So Sk, same meaning. So 3 to the power 4k plus 2 plus 5 to the power 2k plus 1 equals to 14m. 14m because divisible by 14. So to prove that Sk plus 1. The same meaning. So here already I have done the sum. So you can pause the video and you can understand. This one value 5 to the power 2k plus 1. 5 to the power 2k plus 1 is equal to 14m minus 3 to the power 4k plus 2. So 14m minus 3 to the power 4k plus 2. So here calculation is done. Just you can pause the video, you can check it. Because same thing again and again I don't want to repeat and I don't want to explain again and again. So 14 into something, so equals to 14p and the rest of the things you can write yourself. Prove that this type of sum also you have got in exercise 3.3. Exercise 3.2. Show that the square of every integer can be expressed as 3k or 3k plus 1. 3k or 3k plus 1. Square of every integer. So we have taken a be an integer. Because integer is not given here. In the question integer is not given, so we have taken let a be an integer. So a equals to 3m plus 1, 3m plus 2. So this way now. 3 because it is 3 here. In the question 3k or 3k plus 1, so we have taken if it is 2k plus or 2k plus 1, then you could have written 2m. This one already done in exercise 3.2. This type of sum already we did in exercise 3.2. So I don't want to explain again. You can go back to exercise 3.2. You have done already. So a equals to 3m plus 1, 3m plus 2. So when a equals to 3m, both sides doing squaring both sides is done because square of every integer we have to show. It is given in the question. Why we are doing squaring both sides? Because in the question it is given square of every integer. So square is done. A square, 3m square, a square, 9m square, a square, 3 into 3m square, a square equals to 3 into k. In place of 3m square, 3 is integer, m is integer, so 3 into m square also integer. So together this one is taken k. In place of 3m square, you have taken k, where k equals 3m square becomes to z. So a square equals to 3k. So 3k we have got already. So case 1 finished. Okay, 3 we have already expressed this term as 3k. Now we have to express the term, means a square of any integer a square. We have to show a square as 3k plus 1 now. We have already showed a square equals to 3k. Square of every integer, square of a, we have taken integer a. So square of a, that means a square. A square can be expressed as 3k. A square can be expressed as 3k plus 1. So already I have shown here a square equals to 3k. Now we will prove a square equals to 3k plus 1 also. So second case 3m plus 1 is taken. A equals to 3. First we have done a equals to 3m. Now we are going to do a equals to 3m plus 1. Now squaring both sides. A square is equal to 3m plus 1. Squaring just both sides. Why squaring both sides? Already I explained. A square 3m plus 1 whole square, a plus b whole square. 3a square plus 2 ab plus b square. A square equals to 9m square plus 6m plus 1. A square is equal to, from these two we are trying to take 3 common, because 3k plus 1, 3k plus 1, 3 taking common. From these two plus 1 we will keep as it is, because we have to prove 3k plus 1. So plus 1 we are going to keep as it is, because we need that. So from these two we will take 3 common. 3m square plus 2m. So in place of this we will take k again. So that 3k plus 1, because this is an integer, mixed integer, addition of 2 or 3 more integers, 3m square integer, 2m integer. So addition of this integer plus this integer is always integer only. So a square is equal to 3k plus 1, where k is equal to 3m square plus 2m belongs to z. So here we have shown a square equals to 3k. Here we have shown a square to 3k plus 1. So this one no need to do. If you want to do, you can do also, no problem. A equals to 3m plus 2. This one also we can do. Just doing the calculation. Just we'll have to do the calculation. Just both sides squaring. Let me do. You may have some confused. So a square is equal to 3m square 2 into 3m into 2 plus 2 square. A square 9m square plus 2 to the 6 to the 12m plus 4. A square is equal to 9m square plus 12m plus 3 plus 1. This one plus 1 plus 1. Why it is taken separately? Because 3k plus 1. We need plus 1. So plus 1 from 4. 3 plus 1 is done, so that k plus 1 can be shown. A square is equal to, from these 3 terms we can take 3 common. 3m square plus 4m plus 1 plus 1. A square is equal to 3k plus 1, where in place of this k is taken left, where this is an integer. 3m square is integer, 4m is integer, 1 is also integer. So addition of 3 integers always integer only. So we have taken in place of this all k. So where k is equal to 3m square plus 4m plus 1 belongs to that. So a square is expressed as in square of any integer. What is the integer? Integer we have taken let a. A is an integer. So square of a square, 3k plus 1, we can express it 3k plus 1. Same thing here, number 5b also. Here we have to express 9k plus 1 and 9k plus 8. These 3. So a be an integer. So a equals to 9m, 9, like previous sum what we have taken. You have taken express to express as 3k or 3k plus 1. So we have taken a equals to 3m plus 1, 3m plus 2. If it is 4k, we could have taken 4m plus 1, 4m plus 2. In this sum now, in this sum it is given 9. So we have taken 9m plus 1, 9m plus 8. So what is the cube of any integer? Cube of any integer. In the previous sum it was given square. So squaring both sides done. Now cube given. So we will do cubing both sides. So a equals to 9m. First one we are doing 9m. We will have to try to get 9k plus 1, 9k plus 8. So a cubing both sides. Why it is done? Because it is written cube. You can see exercise 3.35 number B. Cube of any integer. What is the integer we have taken? Let, that is a. So a cube equals to 9m whole cube. So a cube equals to 9 9 is 81. 81 into 9 is 729m cube. A cube is equal to 9 into 81 m cube. A cube is equal to 9k, where k is equal to 81 m cube. 81 m cube is integer. So since it is a mixed integer, so we have taken one integer. Since we have to prove 9k, so a cube is expressed as 9k. This one is finished. This one is finished. Case 1 is finished. Now case 2, 9m plus 1. A equals to 9m plus 1. Cubing is done. This is a big calculation, so I have done already, but it takes time. So a cube equals to 9m plus 1 whole cube. So a plus b whole cube, a cube plus 3a square b plus 3ab square plus b cube. Calculation is done. Calculation is done. So at last 1 is there. 1 is kept alone separately. And from this 3 terms, 9 is taken common. Plus 1, because 9k plus 1. 9k plus 1. So in place of this, k is taken plus 1. So it is simple. A cube equals to 9k plus 1. This is finished. Case 3, we will go to 9m plus 8. 9m plus 8. Cubing both sides is done. Why cubing is done? Because cube is written in the question. If it is square, then we could have done square. So this is also cubing both sides. 9m plus 8 whole cube. A plus b whole cube formula. Formula is done. So at last what we have got? 512. After doing calculation of a plus b whole cube, we have got 512. 9k plus 8 we have to prove now. Remember that. So we need 8. So 512 we have broken into 2 parts. Divided into 2 parts. 504 plus 8. 504 plus 8 is 512. So till this much, from this 1, 2, 3, 4, we have taken 9 common. So after taking 9 common, this is the term left, plus 8. So in place of this, all these integers, we have taken one integer, that is k. So 9k plus 8. So this is also finished. Number 6, 1. For any integer a, show that 2 divides a into a plus 1 and 3 divides 2a square plus 7. You can check the question. Look here. 2 divides a into a plus 1. It means a into a plus 1 is divisible by 2. So a into a plus 1 by 2 equals to some integer, any integer. So this is what we have to show. And this type of sums already we have done in exercise 3.2. So for any integer a, show that a 2 divides a into a plus 1. This is what we have to prove first. So for any integer, so we have taken a, be an integer, and b equals to 2. Why b equals to 2 taken? Because 2 divides 18. 2 9s are 18. So 18 is equal to 2 into 9. So a equals to bq. What is b? 2. That is why b equals to 2 taken. I hope you understand. Because 2 divides something. 2 divides 18. So 18 is equal to 2 into 9. A equals to bq. You got in previous exercise. Previous part of the exercise. So a equals to bq plus r, bq plus r. Here r is 0. So this is, I think you have understood. This one already we have got in previous chapter, previous exercise. So a equals to bq plus r we have got already, and this is also you have got. This one was a theorem. This was a theorem. A equals to bq plus r, and r is greater than equal to 0, and r is less than b. So a equals to b equals to 2 taken. So a equals to 2q plus r. What is r? In place of b, 2. So r is greater than equal to 0 and r is less than 2. Less than 2. So less than 2. So r equal to 0 and 1. R is less than 2. So till 1 we can write. R is greater than equal to 0 means equal to 0. So 0. This one already I explained in previous part. So putting r equals to 0. Here r equals to 0. So a equals to 2q. A equals to 2q. So a into a plus 1. A into a plus 1 is written here. A into a plus 1. In place of a, what will we write? A equals to 2q. So 2q into 2q plus 1. A into a plus 1. So what we have to prove? A into a plus 1 is divisible by 2, or a2 divides a into a plus 1. So a into a plus 1 equals 2 into something. If we can show, look here, a into a plus 1, if we divide by 2, we get something here. 18 is divisible by 2 or not. How can we get? Because 18 is equal to 2 into 9. So 18 is divisible by 2. 18 is divisible by 3 also. Why? Because 3 into 6. So 2 is there. So divisible by 2. 2 into something. That means 18 is divisible by 2. 3 into something. So 18 is divisible by 3. So a into a plus 1 is divisible by 2 or not. How can we understand? A into a plus 1 equals to 2 into something. If we can show, that will be divisible. So here directly you can q into 2q plus 1. This one integer. So 2p, or even if you don't write a into a plus 1, therefore a into a plus 1 is divisible by 2. Because a into a plus 1 equals to 2 into something. So divisible by 2. So or hence 2 divides a into a plus 1. 2 divides 18. How do we come to know 2 divides 18? Because 18 equals to 2 into something. What? 2 into 9. So a into a plus 1 is divisible by 2. So 2 divides a plus 1. This is finished. So here what we have done? R equals to 0 we have taken. R equals to 0. Now R equals to 1 we will take. If R equals to 1, then A equals to 2Q plus 1 in place of R, 1. So you will do the calculation now. A means 2Q plus 1. Again 2Q plus 1 plus 1. 2Q plus 1. 2Q plus 2. So from 2Q plus 2, 2 can be taken common. So 2Q plus 1, Q plus 1. So here also A into A plus 1 is divisible by 2. Why? Because A into A plus 1 is equal to 2 into something. Therefore, A into A plus 1 is divisible by 2. Hence, 2 divides A into A plus 1. So by putting R equals to 0, divisible by 2. By putting R equals to 1, also divisible by 2. This is finished. Now second one we will see. Second one, there is given 3 divides A into 2A square plus 7. So A be an integer, now B equals to 3. Previous one 2, so B equals to 2. So R equals to 0, 1, 2. In place of B 3 written, R is less than 3. So till 2 we will write. So there are 3 cases here. 0, 1, 2. R equals to 0, R equals to 1, R equals to 2. Case 1, case 2 and case 3. So by putting R equals to 0, A equals to 3Q plus 0. That means A equals to 3Q. So in place of A we will write now 3Q. Okay. 2 into A square. 3Q square plus 7. This one you can write this one. So this one 3Q into 3 square is 9. 9Q square, 18Q square plus 7. So after that this one 3 into something. So A into 2A square plus 7 is divisible by 3. A 3 divides A into 2A square plus 7. A into 2A square plus 7 equals to 3 into something. So it is divisible by 3. So I have not written here. This one you can write yourself. Secondly, R equals to 0 finished. Now R equals to 1. R equals to 1. So A equals to, if in place of R 1, then A equals to 3Q plus 1. So A equals 3Q plus 1. Now we will write A in place of A 3Q plus 1. Again 2 into, in place of A square, 3q plus 1 square plus 7. Now 3q plus 1, 2 into a plus b whole square. A plus b whole square formula. I hope you understand this one. A plus b whole square, a square plus 2ab plus b square. So a square means 9q square. Directly I am doing 9q square to 6q plus 1 plus 7. Next, equals to 3q plus 1, 2 9s 18q square, 18q square plus 12q plus 2 plus 7. 3q plus 1, 18q square plus 12q plus 9. So from here we can take 3 common because our aim is to get 3. So 3 common, 3q plus 1, 3 6 ja 18, 3 4 ja 12. So it's divisible by 3. So 3 divides a into 2a square plus 7 in case 2. Now case 3, r equals to 0 we have done, r equals to 1 just now we have done. Now we will do r equals to 2, 0 1 2. So a equals to 3q plus 2 in place of r2. So a equals to 3q plus 2. Now a into 2a square plus 7. A means 3q plus 2. 3q plus 2 to 3q plus 2 whole square plus 7. 3q plus 2 to 9q square, 2 3 is 6, 12q 4. That means a square plus 2ab plus b square I have done directly plus 7. 3q plus 2, 2 9 is 18q square plus 12q plus 2 into 9 18, 2 into 12 4, 24q, 2 4 is 8 plus 7. 3q plus 2. Now we will take common 3. Common 3 because from here 3 can be taken. Sorry. One more line you can write. No problem. 3q plus 2, 18q square plus 24q plus 15. So now from these 3 terms we can take 3 common. So 3 is written here directly. 3 6 ja 18, 3 8 ja 24 and 3 5 ja 15. So 3 into something. So a into 2a square plus 7 is divisible by 3. Hence 3 divides a into 2a square plus 7. I hope you understand. Same thing here. Same type of sum. Same type of sum for any even integer. Even. It is written even. Prove that 48 divides a into a square plus 20. 48. So it is difficult to do 48 directly. 48 directly. So we will take 2 numbers. So 48 is equal to 2 into 24 and 48 is also 3 into 16. So we have chosen 3 into 16, 3 and 16 because GCD of 3 is means HCF of 3 and 16 is 1. 2 and 24 HCF is not 1. So 3 and 16 is chosen. First we will show a square into a square plus 20 is divisible by 3. Secondly, we will show a into a square plus 20 is divisible by 16. 3 into 6. If a into a square plus 20 is divisible by 3, if a into a square plus 20 is divisible by 16, then a into a square plus 20 is also divisible by 48. So this is what we will prove. So same thing we will do here. here since we are trying to prove first 3, then secondly we will go for 16. So b equals to 3. The process is same. So r equals to 0, 1, 2. R is less than 3. So 3 cases, case 1, case 2, case 3. 3q plus r. A equals to bq, b means 3. So a equals to 3q plus r. So r equals to 0, a equals to 3q. So a equals to 3q, 3q plus 1, 3q plus 2. I have just written separately to make you understand. To make you understand, I have written separately. If r equals to 0, then a equals to 3q. If r equals to 1, then 3q plus 1. If r equals to 2, 3q plus 2. So 0, 1, 2 only we can do. So case 1, a equals to 3q. So a into a square plus 20. A into a square plus 20 only you have to show. A square into a square plus 20 is divisible by 48. So a into a square plus 20 is divisible by 3. First we will show. Secondly, we will show a into a square plus 20 is divisible by 16. Then finally, we will show a into a square plus 20 is divisible by 48. Because 48, if we divide by 3, it is divisible. If 16, also divisible. So it's the same thing. So, okay. So process is same. There is nothing new. So in place of a, now 3q. 3q a square plus 20. 3q 9q square plus 20. So 3 into something. 3 into something we have got here. So no problem. So a into a square plus 20 is divisible by 3. I hope you understand. 3 into anything. We don't have to worry what is there in 3. 3 into anything, we can show that is divisible by 3. Now case 2. Case 2 means 3q. Sorry. Now question is that here it is given any even integer. Even integer. So now if 3q is even, then next even will be 3q plus 2. Not 3q plus 1. Like if 4 is even, then next will be 4 plus 2. It is given in the question even integer. We have got 3 integers, 3q plus 1 and 3q plus 2. But we will choose only 3q and 3q plus 2. If 3q we assume as 4, then this will be 6. This is 5. 4 plus 1, 4 plus 2. Since in the question it is given even, so we will avoid 3q plus 1. So there are 2 cases only. Case 1 and case 2. Case 1 is a equals to 3q. Case 2 is 3q plus 2. I hope you understand why we have avoided 3q plus 2. This is avoided because it is not even, it is odd. If it is 4, this is 4 plus 2. If it is 8, this is 8 plus 2, not 9. So case 2, a equals to 3q plus 2. So 3, so here there will be no space. So a is 3q plus 2. A square 3q plus 2 whole square plus 20. 3q plus 2. This one I will do 9 directly. 9q square. 2 3 is 6 to the 12q plus 4 plus 20. 3q plus 2. 9q square plus 12q plus 24. So 3 will be taken common because we have to prove divisible by 3. 3 3 is 9, 3 4 is 12, 3 8 is 24. So therefore a into a square plus 20 is divisible by 3. Divisible by 3. Hence 3 divides a into a square plus 20. This is number 1. Now we have to prove, as I have told you, 3 and 16. 3 is finished. 3 divides a into a square plus 20. That is what we have already proved. Now we have to prove it is divisible by 16. So b equals to 16. B equals to 16. So r is greater than equal to 0 and r is less than 16. That less than 16 means what? 0 to 15. 0, 1, 2, 3, 4, 5, 6, 7, 8 like this 15. But we will take, wait. So if r equals to 0, a equals to 16 cube. If r equals to 1, then 16 cube plus 1, 2, 16 cube plus 2, like this it will go on. Okay. So now here what we have to take, we have to take even integer. Since even integer, so a equals to 16 cube. Next will be 16 cube plus 2. Next will be 16 cube plus 4. Okay. Then 16 cube plus 6, 16 cube plus 8, 16 cube plus 10, 16 cube plus 12, 16 cube plus 14. Finish. Not 15. Because 15 is not even. So if 16 cube is even, next second term will be even. So we will take even because in the question it is given. So for 16 cube, r equals to 0, a equals 16 cube, r equals to 1. So case 1. Case 1. So possible values for a, 16 cube, 16 cube plus 2, 16 cube plus 4, dot, 16 cube plus 14. So for each one actually we will have to do, but we will not do. We will do 2, 3, 2, maximum 2. After that we can write similarly. Okay, we will do 2 only. 16 cube and 16 cube plus 2. Rest we cannot do. It will be a big sum. It will be a very long sum. So you cannot do all the terms. So we will prove only 2. Rest can be written similarly. So we will do 16 cube and 16 cube plus 2. Let's first case 1, a equals 16 cube, a into a square plus 20. So 16 cube into a square plus, 16 cube whole square plus 20. A square, so 16 cube. So here we don't have to write anything. 16 into something. So therefore a into a square plus 20 is divisible by 16. Now we will go to case 2. A equals to 16 cube plus 2 now. In place of a we will add 16 cube plus 2. 16 cube plus 2 whole square plus 20. Okay, this equal sign should be written here, but there in order to make the space, so I am writing here, I am putting equal sign here. 16 cube plus 2. 16. This calculation already I have done here, so let us see. 256 q square. So a plus b whole square formula. 256 q square. 2 to the 464 q plus 4 plus 20. 16 q plus 2. 256 q square plus 64 q plus 24. So from these two we can take 2 common. 8q plus 2. From these 3 we can take 8 common. 8 into 8 is 24, 8 to the 16, 32 q square, 8 8 is 64, 8 3 is 24. So 2 into 8 is 16. 16 into something. So this should be 1. 2, 8q plus 1. Okay. 2 into 8 is 16. 8q plus 1. 32q square plus 8q plus 3. So a into a square plus 20 is equal to 16 into something. So a into a square plus 20 is divisible by 16. Hence 16 divides a into a square plus 20. This is number 2. So from 1 and 2 we get in 1, what did you get? 3 divides into what did you get? 16 divides. So 3 into 16 divides a into a square plus 20, or 48 divides a into a square plus 20. If a be an odd integer, prove that 24 divides a into a square minus 1. So 24 also we have taken 3 into 8, because 3 into 8 HCF is 1. When 6 into 4 we will not take, because HCF of 6 into 4 is not 1. So we have taken 3 and 8. Like previous sum, divisible by 3 and divisible by 8. So finally we will prove divisible by 24. But here it is odd. Remember that it is odd. Previous sum it was even. Okay, like same thing, b equals to 3, first 3, so b equals to 3, so r equals to 0, 1, 2. R is less than 3, so till 2. So a equals to 3q, first 0, r equals to 0, so 3q plus 0, 3q, r equals to 1, 3q plus 1, r equals to 2, 3q plus 2, 3q plus 1, 3q plus 2. Now a is an odd integer. So if 3q is odd, then next odd will be 3q plus 2. If 7 is odd, next will be 9. That means 7 plus 2. So if it is 7, 7 plus 1, 8, 7 plus 2, 9. I hope you understand. This is suppose 7. Assume this is 7. So this will be 7 plus 1. This will be 7 plus 2. So it is written odd. Odd, no? So odd will means this is odd and this one is odd. So we will have two cases. 3q and 3q plus 2. Case 1. A equals to 3q. So what you have to prove? A into a square minus 1. A into a square minus 1 is divisible by 3. We have to prove. A into a square minus 1 divisible by 8. We have to prove. But for 3, two cases are there. One for a 3q. Second case 3q plus 2. So for 3q we have to show it is divisible by 3. For 3q plus 2 also we have to show it is divisible by 3. Let us see now. 3q into 9q square. Directly I have written because 3 into something. So therefore a into a square minus 1 is divisible by 3. Because a into a square minus 1 equals 3 into something. So case 2. Case 2, a is equal to 3q plus 2. 3q plus 2. So now a into a square minus 1. A into a square minus 1. A means 3q plus 2. 3q plus 2 whole square minus 1. 3q plus 2. 9q square. 2 to the 6 to the 12q plus 4 minus 1. 3q plus 2. 9q square plus 12q plus 3. We will take 3 common now. 3q plus 2. From here we have taken 3 common. 3 3s are 9. 3 4s are 12. 3 1s are 3. So therefore 3 into something. So a into a square minus 1 is divisible by 3. Hence 3 divides a into a square minus 1. Number 1. Number 1. Now we will try to prove for 8. So b equals to 8 now. B equals to 8. So 8 means what? R equals to 0, 1, 2, 3, 4, 5, 6, 7. So 7 cases are there. But among these 7 all are not divisible because odd integer. So 8q plus 0, 8q plus 1, 8q plus 1, 8q plus 2, like this till 7. But since a is an odd integer, so we will take first one 8q. 8 into something is always even. So this one is avoided. 8 into anything is always even. So next will be 8 into anything plus 1 is odd. So if this one is odd, this one surely not odd. Next will be 8q plus 3, 8q plus 5, 8q plus 7. So 4 cases, but we will do only 2. Rest similarly we can write. Okay, now let us go for 8. A equals to 8 cube plus 1, 8 cube plus 3, 8 cube plus 5, 8 cube plus 7. We will do only these two. A equals to 8 cube plus 1. What was the sum term? A into A square minus 1. A into A square minus 1. So A means 8 cube plus 1. 8 cube plus 1 whole square minus 1. 8 cube plus 1. 8 is just 64. Q means A plus B whole square. 2 is just 16 Q plus 1 minus 1. 8 Q plus 1. 64 Q square plus 16 Q. Plus 1 minus 1 cancel. So here we can take 8 common. 8 8 just 64. 8 2 just 16. So 8 into something. Therefore, A into A square minus 1 is divisible by 8. Why 8? Because 3 into 8. 3 already finished number 1. Now we are trying to prove for 8. Now second case. Case 2. A is equal to 8 cube plus 3. Second one we are taking. We will not do all. A into A square minus 1. 8 cube plus 3. 8 cube plus 3 whole square. Sorry, minus 1. Minus 1. So I am doing here 8 cube plus 3. 8 is just 64. I want to do directly. 64 q square. 2 is just 16, 3 is 48 q plus 9 minus 1. 8 q plus 3. 64 q square. 48 q plus 8. We can take 8 common. 8 we have to take common. 8 8 just 64. 8 6 just 48. 8 1 just 8. So 8 into something. So A into A square minus 1 is divisible by 8. Similarly, for A equals to 8 cube plus 5, 8 cube plus 7, A into A square minus 1 is divisible by 8. For A equals to 8 cube plus 1, we have proved. For A equals to 8 cube plus 3, we have proved. So 8 cube plus 5 and 8 cube plus 7, we are not going to do again and again. So it will take time and it will be a long sum. Now it is not required also, so similarly. So hence 8 divides A into A square minus 1. This is number 2. So from 1 and 2 we get 3 into 8 divides A into A square minus 1, or 24 divides A into A square minus 1. Hence proved. Compute by using Euclidean algorithm. We have to use Euclidean algorithm. So Euclidean algorithm already we have got. Euclidean algorithm already I have shown and already have there is in the book. That means we have to divide and we have to show GCD of 72 into 72 and 120. So let us do 72 120. How much? 7 to 1. 72 48. 72 again 48. 4 24. 48, 24 to the 48, remainder is 0. So this is GCD. This one is a process already I explained in the explanation. In previous video, I already explained how to find the GCD with the help of Euclidean algorithm method. So how to write now? 120. 120 is equal to 1 into 72 plus 120 is equal to 1 into 72 plus 48. So plus 48. Next, 72. 72 is equal to 1 into 48 plus 24. 1 into 48 plus 24. Next, 48. 48. 2 into 24 plus 0. 2 into 24 plus 0. So when we get remainder 0, this will be the GCD already I explained. Therefore GCD of 72, 120 is equal to 24. So number 2 and 3 you will do yourself. That can be done. This one I am not going to do. 13, 18, same process is same. Number 8. Number 8. Find two integers u and v. Find two integers u and v such that 20u plus 63v equals to 1. 20u plus 63v equals to 1. This is given actually. We have to find out the value of u and v. So by the method of division algorithm, so 63 and 20. 20 is smaller. 63 and 20, 20 is smaller. So we have tried to find out the GCD of 20 and 63. So by 20 divided 63 like this going on. So here 0 remainder. So 1 is GCD. Okay. So division algorithm. So that's previous sum already done. 63 equals to 3 into 20 plus 3. 20 equals 6 into 3 plus 2. 3 equals to 1 into 2 plus 1. 2 equals to 1 into 2 equal plus 0. So GCD of 20 is 63. This is the GCD. So it is GCD. Now what to show? 1. So here where we have got 1. This is 1. Now here it is 1. So from 1 instance. So 1 is equal to 3 minus 1 into 2. 1 is equal to 3 minus 1 into 2. So 1 is equal to 3 minus 1 into 2. This is we have got I have put here. Why 1 is starting is from 1? Why? Because it is given in the question 1. So okay. Now 3 kept as it is minus 1 kept as it is into 2. So where is 2? 2 is here. 2 is equal to 20 minus 6 into 3. 20 minus 6 into 3. So 3 keep as it is minus 1 into 20 minus into minus plus 6 into 3. 1 into 3 written 1 into 3 minus 1 into 20 plus 6 into 3. Okay, this one 3 I have written 1 into 3. 1 into 20 kept as it is 6 into 3. Look here 1 into 3 plus 6 into 3 will be 7 into 3. Why? It is like 1x plus 6x. What is x? What is x? 3 is x. So 1x plus 6x is 7x. 7 into 3. 1 into 3 plus 6 into 3, 7 into 3. I hope this one already I explained several times. So I hope you understand. Now 7 into 3 minus 1 into 20. So 7 into 3. So 1 is used, 2 is used, now 3. We have got 3 here. So 3 means 63 minus 3 into 20. In place of 3, 63 minus 3 into 20 written. This one came from here. I hope you understand. Minus 1 into 20 is kept as it is. So 7 into 63, 7 into 3, 21 into 20, 7 into, sorry, minus 1 into 20. So we are trying to get 63 and 20, 63 and 20. Our aim is to get 63 and 20 anyhow. So 63 we have got already. So this one we are not going to change anywhere. Now minus 2 into 1, 21 into 20, minus 1 into 20. It is like this, minus 21x minus 1x will be minus 22x minus 21 into x minus 1 into x is minus 22x. Same thing, minus 21 into x minus 1 into x is minus 22 into x. X is 20. So 20u, first 20u is there. So this one let us write first. Then 7 into 63. 20u, 20 into minus 22. This one same thing, I have written 20, I have written first. Let us wait, some technical problem. There is some technical problem in the board. Okay, it is already ended up. Okay, minus 22 into 20 is written 20 into minus 22 because 20u plus 63 into 7. So 20u plus 63v. Therefore, u is equal to minus 22, v is equal to 7. I hope you understand. 20u plus 63v. So here 1 is equal to 20u plus 63v. 1 is equal to, it is given here. So that is why we have started from 1. Or we can write separately here if you have a problem of understanding. So we can write therefore 20 into minus 22 plus 63 into 7 equals to 1. Well, equal sign from where it comes? From here it came. 1 equals to 1. So 1 equals to this one. So this equals to 1. So now u equals to minus 22, v equals to 7. I hope you understand. This is same. This is also same. 30u plus 72v equals to 12. So by division algorithm, 30 and 72. 30 and 72 division is done. Short process division is done. So like this 6 is HCF, means GCD. 6 is GCD, so same thing you have done. 72 is equal to 2 into 30 plus 12. 30 is equal to 2 into 12 plus 6. 12 equals to 2 into 6 plus 0. 6 is the GCD. So we will start the sum from 12. Or we can do from 6 also. Because 6 we can do by 12. 6 and 12 meaning is same. So we have started from 6. So 6 equals to 30 minus 2 into 12. 30 minus 2 into 12. 30 minus 2, 12. This one done already. 12. 72 minus 2 into 30. So 32 into 72. Minus into minus plus 2 into 2, 4 into 30. 1 into 30. This one again you may not understand. 6 is equal to 1 into 30. 30 means 1 to 30. 2 into 72 plus 4 into 30. 1x plus 4x equals to 5x. That means 5 into 30. Here 30 and 72. So 30 we have got already. 72 also we have got already. But right hand side there is 12. But there is 6. So we will multiply both sides by 2. So that we get 12. 6 into 2. 2 into 5 into 30. Minus 2 into 7. Both sides multiplying by 2. Why? 6 into 2 is 12. But there is, because there is 12. Okay, so 12 is equal to 10 into 30 minus 72. 4 into 72. Now we can write or 30 into 10 plus 72 into minus 4 equals to 12. I hope you understand. Plus is there. There is plus. So we have plus. So minus 4 taken separately. So therefore, U is equal to 10 and V is equal to minus 4. This one you will do yourself. This one also same thing. Number 9, 1. For any integer a, show that GCD of 2a plus 1, comma 9, GCD of 2a plus 1 and 9a plus 4 equals to 1. GCD is 1. This is what you have to prove. For any integer a, show that GCD of these two terms is 1. So let D be the GCD of 2a plus 1, 9a plus. We have taken D as GCD of 2a plus 1 and 9a plus 4. If D equals to 1, if we can show D is 1, then GCD of 2a plus 1, 9a plus 4 is 1. Okay. So we will try to prove D equals to 1. So if D is GCD of 2a plus 1, 9a plus 4, so D divides 2a plus 1, D also divides 9a plus 4. Look here, example. 8 and 6. What is the GCD? 2. GCD of 8 and 6, 2. So 2 divides 8, 2 divides 6. This is like D. Here we have taken D. D be the GCD of 2a plus 1, 9a plus 4. So D divides 2a plus 1, D also divides 9a plus 4. This is what I have written here. D divides 2a plus 1 and D divides 9a plus 4. So there is a theorem in the previous exercise, previous part, previous video already I explained. A divides B and A divides C, then A divides Bx plus Cy. It is in page number 113, theorem number 38. Page number 113, theorem number 38. Page number 113, theorem 38. 38. If A divides B and A divides C, then A divides Bx plus Cy. So this is A divides B, A divides C, with this x comes, with this y comes. So 2a plus 1x plus 9a plus 4y. I hope you understand this one. With this x multiplied, with second one y multiplied. D divides this, D divides this. A divides B, A divides C. Sorry, B. A divides B, A divides C. A divides Bx, Cy. Taking x equals to 9, y equals to minus 2. Why it is taken like this? Because this one into this one and this one into this one, we have to get cancelled. We have to get cancelled. X should be getting cancelled. How can we get cancelled? If we take x equals to 9, 9 to 18, y equals to 2, 2 equals 2 9 is 18, but 1 should be minus. Then only 18a minus 18a cancel. So taking x equals to 9, y equals to minus 2. So in place of x 9 written, in place of y minus 2 written, 9 to the 18 minus 18. So this is written plus 18 minus 18 cancel, plus 9 minus 8 1. D divides 1. Plus 9 minus 8 is 1. D divides 1. It is possible if and only if D equals to 1. 1 divides by 1 only, nothing else. 1 can be divisible by 1 only. That means in place of D also there should be 1. So D be the GCD of 2a plus 1, 9a plus 1. So D we have got 1. That means GCD of 2a plus 1, 9a plus 4 is 1. Nine 2. For any odd integer a, show that GCD of 3a plus 2 is 1. Like previous sum only. Like previous sum only I have done. You can pause the video, you can note it down. Just like same only. Because there is nothing else. Odd integer, so 3a. Similarly, same theorem number, same theorem 3, 8. Same theorem we have to apply. Here x equals to 1, y equals to minus 1. Because 1 into 3a is 3a, minus 1 into 3a is minus 3a, so that you can get cancelled. D divides minus 2. So it is here d equals to 1, minus 1. D divides minus 2 means what? 1 divides minus 2, minus 1 divides minus 2, 2 divides minus 2, minus 2 also divides minus 2. But minus 1, 2 and minus 2. This one we are not going to take because 2 and minus 2 they are not odd. 1 minus 1 also not odd. So D equals to 1. Because minus cannot be. In GCD we don't get any minus. Minus is totally avoided. In previous video, previous part we have already explained. The GCD cannot be minus. GCD cannot be negative. So minus is cancelled. 2 and minus 2 both are even, but there is an odd. So D equals to what? 1. So GCD of 3a plus 2 equals to 1. Number 10. Find LCM of 306 and 657. In the previous classes or in the general math we have got, if we know HCF, if we know LCM, one number and another number, so there is a formula HCF into LCM into one into other. So any HCF is LCM. If we want to find out LCM, first we will find out HCF. So LCM is equal to one number into other number divided by HCF. Same thing here also. LCM into GCD equals to one number into other number. So let us find out first HCF means GCD. So 306, 657. I have found GCD. GCD is 9. GCD is 9. So in place of GCD 9 is written. So LCM is equal to this into this by 9. So this multiplication it is done. Pause the video and note it down. So it is finished, I think. Okay. So second one, 111,270. Exactly same process. Exactly same process you will apply. You will get easily this one. First you will find out like this process. For 306 and 657, whatever you have done, you will do for second part also. 111 and 270, you will get the answer. So till then, the exercise is finished. So next video, I will explain 3.5, page number 133. That means I will explain for exercise 3.4. So till then, have a good day.